Good morning, students. Welcome to another video lecture. So today we are going to discuss about positive clamper with positive bias. So last two classes, I discussed about positive clamper and negative clamper. So today I'm going to discuss about positive clamper with positive bias. So when I'm saying this term positive bias, that means when I'm saying it's a positive bias, I am basically using a voltage source or a reference voltage that is termed as Vs here. So you can see here I am using a VB voltage source here, so which is connected series with the diode. So the circuit remains same as the positive clamper, but only a extra voltage source is added. Like in this manner, positive is connected to P side of the diode, negative is connected to the N side of the diode. So now as I told before, when the diode will be forward biased, at that time only the capacitor will charge. So you can see here the load resistance RL, the voltage source VB and diode connect together. It's both are parallel. So voltage. So as you can see here, these two nodes are same and these two nodes are same. So both are parallel. So if we apply KVL here, so I'll get the same equation. So you can write down here like minus to plus VI, then plus to minus VC. So VC is the voltage drop across capacitor as I told. Then so across this we have a voltage drop V0. So minus V0 equal to 0. So our main objective is to find out the output voltage V0. So V0 equal to Vi minus Vc. V0 equal to Vi minus Vc. This is the output voltage equation. So here our main objective is that Vc, to find out Vc, because Vc is unknown. Vc is unknown, and Vc is what? The voltage stored across capacitor. And when the voltage can be stored across the capacitor, when the diode will be forward biased. So one thing you have to remember here, the maximum voltage whatever I'm taking at the Vi, this is Vm sin omega t. So this Vm sin omega t, the maximum voltage, this Vm should be greater than Vb. The Vm should be greater than Vb. Okay. So now you can see, as I told in the positive bias case, as a positive clamper case. So when this input voltage is positive, when I'm providing input voltage positive, so at that time the diode will be reverse biased. The diode will be reverse biased. So the diode will open circuit. So the capacitor will not going to charge. But when I'm taking the negative half cycle, here, then only the diode will be forward biased and the capacitor will charge. And when the diode is forward biased, it acts as a short circuit. So by giving this negative voltage, when I'm providing the negative voltage, so the polarity of the input voltage remains changed. So this will be minus, this will be plus. You can see here, this will be minus, this will be plus. The diode will be forward biased and short circuit. So I can draw the same diagram. So I can draw the same diagram here. So you can see this is the diagram. By redrawing the diagram, I will get like this. So from this diagram, we can find out what is the capacitor voltage. So we can see here the Vi connected reverse. So Vb is the reference voltage or bias voltage, as it is connected like this, negative and positive. I am connecting here. The diode is forward biased or short circuit, and the capacitor voltage is like that, left hand side positive, right hand side negative. If we can apply KVL here, and we can write down the KVL. So I'll write down plus to minus Vi, then minus Vc, then minus Vb equal to 0. That means if I solve this equation, I will get Vc equal to minus of Vi plus Vb. Okay, so this is the capacitor voltage. I got it. Okay, so this capacitor voltage, I'll put it here. This capacitor voltage, I'll put it here. So let me put this put this capacitor voltage here. So I'll get here V0 equal to basically Vi minus Vc. So we have this Vc nothing but minus of Vi plus VB, Vi plus VB. Okay, so one thing I forgot to write here. So the capacitor, when it is charging, it can charge up to the maximum voltage. So maximum voltage of this Vi equal to nothing but Vm. So I can write down Vc equal to minus of Vm plus Vb. Minus of Vm plus Vb. So here I can put the same thing. So let me correct here. Okay, so I'll write down Vi minus of minus Vm plus Vb, minus of Vm plus Vb. So I'll get V0 equal to Vi plus Vm plus Vb. This is the our output voltage equation. So in this output voltage equation, as I told, this Vb is the reference voltage and this Vm is fixed. This value is fixed. Only the Vi is variable. So only the Vi is a variable. So I can put it here. If Vi equal to 0, if Vi equal to 0, so I'll get here V0 equal to Vm plus Vb. Okay. Next I can take Vi equal to minus Vm. If I'll take, sorry, if I'll take, wait a minute, if I'll take Vi equal to Vm, if I'll take Vi equal to Vm, so I'll get V0 equal to 2 Vm plus Vb. Similarly, another point I can take, if Vi equal to minus Vm, so I'll get V0 equal to Vb. So all these things I am putting in this equation to get the output. Okay, so I'll get all these conditions. When Vi equal to 0, V0 equal to Vm plus Vb. When Vi equal to Vm, V0 equal to 2 Vm plus V. And when Vi equal to minus Vm, I got V0 equal to V. So let me draw this diagram for this input voltage and output voltage. So let this is your input voltage Vi. I am taking Vi. This is the maximum voltage Vm. This is the minimum voltage minus Vm. Let me draw the output voltage here. Let this is your uh, omega t. This is also omega t. This is pi. This is 2 pi. And I told that this is the input voltage. So I'll mark it here. Let this is your VB. Let this is your VB. This is your Vm plus VB. This is your 2 Vm plus VB. 2 Vm plus VB. Let me draw a line. Okay. So you can see here when Vi equal to 0, when Vi equal to 0, that means at this point, when input voltage is 0, at that time output voltage will be Vm plus Vb. The output voltage will start from the Vm plus Vb. So the output voltage, let me draw another line here. Okay, so this is the initial point. When Vi equal to Vm, when Vi equal to Vm, the output voltage reaches at 2 Vm plus V. So if I will draw the diagram, I will get a equation, I will get a curve like this. Okay. Then when Vi equal to minus Vm at this point, at that time V0 equal to Vb. So V0 equal to Vb. Okay. So this is your pi, this is your 2 pi. So this is basically your output equation V0. So now you can see here the input voltage starting from 0 going to maximum voltage Vm, then coming back to 0, then minus Vm, then again 0. Same thing, we can see the output voltage is starting from Vm plus V, reaches are 2 Vm plus V, again reaches to Vm plus V. Then in the negative side, or in the I'm getting the voltage VB. Okay, so if I can check here, if I can check here, if the peak to peak voltage, peak to peak here also getting 2 Vm. Same thing if I can apply here. So 2 Vm plus V and my 2 Vm plus V minus VB. Here also I will get V peak to peak equal to 2 Vm. Okay, remember one thing. Now you can see here, as I am providing a voltage here, as I am providing a reference voltage or bias voltage VB, so I am getting the equation starting from Vm plus V. The equation starting from Vm plus V, and it is shifting upwards. It is shifting upwards in the positive direction. So it is basically I'm saying the positive clamper with positive bias. So its minimum value, the output wave's minimum value is VB. So if the bias voltage is VB, if the bias voltage is VB, then the equation and the maximum voltage is Vm for the input equation, the maximum voltage. Then our waveform, the output waveform always starts from the Vm plus Vb. Our output waveform always starts from the Vm plus Vb. Okay, so this is all about your positive clamper with positive bias. Similarly, you can solve negative positive clamper with negative bias, or negative clamper with positive bias. Okay, I hope you understand this numerical. If you have any doubt, you can ask me in the comment section, or if you like the video, you can share the video with your friends. Thank you for listening.